Good afternoon and welcome to today's EHS Today webcast, Ergonomics, Operator Compatibility, Guidance for the Designer, Supplier, and End User. I'm Stephanie Valentic, Associate Editor for EHS Today, and in a moment I'll be turning things over to our speaker. I would like to thank Pills Automation Safety for sponsoring this afternoon's webcast. I would like to remind all of you that if any time you experience audio difficulties or advancing of the slides, simply press your F5 key to refresh your webinar console. I would also like to encourage all of you to ask our panel questions. As a question occurs to you, simply type it into the box on the right-hand side of your screen, and we will be addressing as many of your questions as we can at the end of the presentation. Lastly, slides may be downloaded in the green folder at the bottom of your webinar console. Now let me introduce today's presenter. Doug Sen, PhD, CSP, CMSE, is a safety consultant with Pills Automation Safety LP. He has over 25 years in the plastics machinery industry, employed as a consultant, and over 20 years participating on U.S. and international safety standards committees. He has worked for Pills since January 2014. For more information about our speaker, click on the speaker widget on your console toolbar. Now let's get this presentation underway. With that, Doug, the floor is yours.
Thank you. Good morning, good afternoon. Let's get started. The objectives. What is ergonomics? What standards are available for guidance? Why is it so important to design safety? What percentile of men, women do we consider? Who will be working with or operating the machine? What tasks will be performed on the machine? Is there some type of recognized checklist? What fundamental applications can be served? What is ergonomics? Simply put, we're designing the machine to fit the capabilities and the limitations of the operator rather than vice versa. This may be an overt exaggeration, but most people look like this when they're working with a particular machine. But there are some designers who think people are shaped like this. So these are issues that we have to address as we design machines to fit those capabilities and limitations of the operator. In design review, and this is the area particularly at the conceptual stage, is we need to define the production process. We're talking about materials, we're talking about operations, we're talking about cycle time. And in that, we move on to determine the characteristics of the worker population, the physical, the mental capabilities and limitations. And this filters down to design the machine and the operational tasks to match users' capabilities and limitations, which then drops down and filters down to assess the match and the usability test. Does the proposed design optimize the performance of the operator? Are we making it productive, efficient, comfortable, and being able to minimize the risk of injury? I want to share this with you. There was a couple examples that I want to spend some time with you as to practicality for applying ergonomic design. One is, take for an example, Anthropometrics, selecting of body dimensions. You'll see on the left side there are certain criteria, certain factors, and as you move to the right, the population percentiles. Now we're talking about in inches, we're talking about males, females. So as we go forward in our examples, if we're talking about building or designing an access way from one room to another, we want to use the 99 percentile because we want to make sure everybody can walk through that particular doorway. If we're talking about designing a shelf where we have tall people and short people, we want to look at the 5 percentile because we want to make sure that the shorter person can reach the top of the shelf without having to get a stool or a chair. Hopefully not a chair. So as we move on, you can see it's 5, 50, and 95 percentile with a standard deviation. So what I'd like to do is walk through an example of how we make determinations based on our design as a supplier or as an end user within our own organization. So you can see here, where do you stand? Let's say, for example, we want to calculate the height of the 98th percentile of the male, where your 50 percentile of males, the X with the line over, is 69.1 inches. And you can see the formula is the percentile, 50% percentile, plus the Z factor, which is above in the chart, and the standard deviation, which is the circle with the dash line at the top. As we go through the formula, you can see at the end of 98th percentile, we're talking about a male being in the height range of 74.66 inches without shoes. Now, let's take that same situation, but now we're going to talk about someone in the 25th percentile where, let's say, we're building a shelf where we have males, females, so we have to take in consideration those variations in height. So you can see by the calculations, instead of adding the Z and the standard deviation, we're subtracting that, where 69.1 is the 50 percentile, the 25 percentile is 67.29 inches. One of the examples that I want to spend some time with, in many industries, though there is an automatic processing of material in a particular machine, there are still other machines out there where two-hand controls are being used not only in production, but also sometimes in a setup mode, also in a maintenance mode. So there's three major ergonomic designs to be considered in the use of palm buttons. We have cup and ring guards. We've all seen those. We have palm button locations. Are they in front or they're above the point of operation where we have to reach above? And then we have button forces. Now we're talking about CTDs are a real pain. And the fact of it is, when we're talking about cup and ring guards, first item is we got to prevent anti-bridging and unintentional operation, slightly higher than the plane of the palm button. And as most of you are aware, particularly for OSHA, whether it's federal, state standards, they put these protective rings in to prevent bridging. And what it has done is that we can no longer use the palms of our hands to actuate. Now we're talking about the heel or our fingers being used, and this puts stress, in those particular areas. And as we said, this can result in ergonomic problems. The operator, as I mentioned, uses fingertips or the heels of the palms to activate the buttons, creating high stress on fingers and palms. Now, we talked about location, location, location. And this is not an ad for a real estate organization, but in designing for ergonomic applications dealing with safety, this is extremely important when we talk about palm button location. Palm buttons located at or near waist height. That's where they should be from a biomechanical application. Palm buttons should be oriented at approximately the same angle as the forearm in order to minimize wrist deviations. We talk about button forces. Typical palm buttons are required depression of 1 centimeter, basically it's 1.25 centimeters, or half an inch to be engaged. We don't want to push them too far to engage them. Again, we're talking about forces. The palm button engagement forces must not exceed the physical capabilities of the operators, and normally those are a force of no more than 5 pounds to actuate the buttons. Now, the force be with you or not. Here are a couple applications which are relatively new in technology. The first one is swipe controls. This is no force. These can be used with gloves, particularly from the standpoint if you're in an industry where you're handling sharp components or those at high temperature or cold temperature. So they will pick and read these. There's no force. It's just swiping your fingers across it, and you can use gloves. The other is repositioning the palm buttons vertically. This is the removal of the ring guards. It's more in line with natural biomechanical movement. Actually using the palms of your hands. What a novel idea. You have them on the side. It reduces two types of movements of turning the wrist and then causing a flexion for pushing the controls down through your protective ring. So these are two particular designs that are very, very beneficial, particularly on machines that you have to actuate the cycles every time you put a part in or remove a part from a machine. Now, here are some of the comparisons between humans and machines. You can see that humans excel in sensitivity, the ability to react to unexpected, low probability events, able to exercise good judgment in most cases, the adaptability to changes, perception of patterns. Now the machines, they're performing routine, repetitive. They are doing the same thing over and over again, and you have some very precise operations. They exert great force smoothly and with precision, as mentioned. They're operating in environments that sometimes are hostile to humans or beyond human tolerance, being insensitive to extraneous factors. And as far from a machine, as those in the guarding aspect, machines are insensitive to the operator. Could be tall, could be short, could be male, could be female. It doesn't make a difference to the machine. From the ergonomic perspective, from a safety perspective, things need to be assessed. And then doing many different things simultaneously. Let's go mining. What are some of the critical questions for designing for operator compatibility? Now, operator compatibility is we want to provide a safety system that protects the operator, reduces those risks to an acceptable level, or eliminate those hazards. But also we want to make sure that the operator or maintenance person can operate the machine in a productive and efficient way. So it's a two-way street when we talk about operator compatibility. What does the individual have to do to operate the machine? How high should the work surface be? Is it standing or is it a sitting type of operation? Can machine jams be safely and efficiently cleared? How will the machine setup or servicing tasks be performed? How will the machine be loaded and unloaded? Will there be room to perform maintenance efficiently? And what machine guarding designs are most compatible? And I want to make a couple notes regarding this last item. Are we going to use fixed guards or are we going to use interlock type guards? Now, fixed guards, are they heavy? Are they light? How are they installed? Do we put more screws and bolts into the guard where we really need them? Do we use captive bolts where from the standpoint they're always with the guards? Interlock guards. Questions. Do I want a sliding guard? Do I want the guard to open left or right on a hinge? Do we want it to open up as a gull wing application? So there's things to consider because an interlock guard is where we place the HMI system to make it not only convenient, but also we want to be able to do the process in the most proficient and the most productive way. So these are things that take into consideration that are ingrained into safeguarding design applications. Proactive versus reactive. And here's some things from the standpoint of ergonomic risk reduction. You're dealing with the designer, In the design, we have to talk about also the instruction manual, whether it's from operations and from a maintenance or setup application. Then we have the protective measures dealing with the installer, and there's certain elements that are a concern. And then it moves down to the end user. Now, you can see it's a continuous cycle. The end user should be in a position to understand what standards apply to their particular machine or their particular environment and supply that feedback to the supplier or the designer of that particular organization. I caution you, if you don't ask for those particular applications as they deal with ergonomics, 9 times out of 10, you won't get them unless you ask for them and have them in your design requirements. So I do want to stress the fact that it is a continuous cycle, is that what you're using, you can go back, and how you need to use this and what your requirements are is very important feedback in a positive way back to the designer and to the supplier. Show of hands. Here are some of the positions that are basically risk factors. And the flexing on the left is basically the one we talked about, the two-hand controls. You can see I'm flexing my wrist almost at a 90 degree. Now in that position, I'm pushing down my fingers to actuate two-hand controls. Working shoulders down. Here's another area from the standpoint. I take the second one from the left, reaching behind the torso. In a lot of cases, setting up manual operations such as packing, having parts stationed behind the individual where they're constantly, maybe every 15 or 20 seconds, they're reaching behind them to pick up a part. No matter what the weight of it is, it's just the exercise of reaching beyond a point and the repetitiveness that can cause issues, where in particular cases, that particular bin of parts could probably be put to the side to reduce that reaching behind exercise. Now, this is important because in the European standard, they ask or require that you design for the 99 percentile. Now, the 99 percentile of who? Is that males? Is that females? We're talking about North America. We're talking about European, Asian, Latin America. We're talking about your particular industry. If you're in the heavy metals, are you in the plastics industry? What is the relationship as to the male-female workers out on the floor? So here is some things that you need to look at as they apply, particularly not only as a designer and supplier, but also as an end user for your particular type of operations. Workstation, sample applications. One thing I wanted to show you is that, and share with you, coming out of the plastics industry, it's a lightweight industry. We're making plastic bottles. They're not very heavy. However, when doing an analysis, finding out that 60-65% of your factory workers are females. So taking that in consideration as an end user, I have to look at that as to designing certain criteria. Work height, reach, display height. Very important. Display height. From the standpoint, when we're in our 20s, we have monovision. But like some of us, when we get to 40, we're going into bifocals and maybe trifocals. So we have to take into consideration individuals. So it's important that if you're designing machines or you are requiring a particular design as an end user, to look at this from the standpoint, the optimum is to basically ask for an adjustable height HMI system that would accommodate a range of heights for your particular operation. The last one about foot clearance. A lot of this is an issue dealing with ladders. We're going up fixed ladders. Not only is it a standard, an ANSI standard, but again from the standpoint of designing fixed ladders, it's very, very important to have this clearance for basically for preventing falls and slips. Okay, keep it in a control zone. And you can see here from the standpoint of reaches, how far it should be from center. We have some occasional reaches where we go to 22, 26, but we want to keep it within a 14 to an 18-inch range. And you'll see different dimensions, but if you stay within that 14, 18%, and that's a reach, again, depending on what the frequency is, based on what the weight of that particular part that you are reaching for or picking up, will also have a bearing on your design. Take a stand. As you can see here from the standpoint is elbow height. We're talking about a light product, we're talking about a medium weight product, or particular products that are heavier as to where that should be in relationship to your body. Sort of a lineup card. Here are some of the things when you're out there doing an ergonomic assessment, whether it's on the machine, as a designer, and that particularly of a installer, or from the standpoint as an end user. And a lot of times, a good way to do your assessment for ergonomics is to videotape the process. You will find a lot of things out, and video does not lie. So when people say, well, I don't do this, and I don't do that, and this is too low, and this is too high, take video and then get your risk assessment group committee together and to analyze what you need to do, again, as a designer and as an end user. And you can see the different types of issues that people become associated with. Continuing, the butts up, twist and shout, where you're picking a particular product off the conveyor belt, making a twist. Those are situations that will lead to some very, very hazardous situations, and that being that of personal injury. Horizontal distance, you can see a sit or stand, but you can see in that particular slide that the worker is sitting sideways and turning their body at a 90-degree and trying to do a particular type of task. So these are things that sometimes we do not take into consideration, both from a design, supplier, and possibly in the end user's capacity. Bad vibes, contact. These are some of the other areas that we need to take a close look at. Now, proactive approach to safe design. 6 ways to apply ergonomics in design. Start to finish. We do establish an ergonomic design specification. What do we want to put into our design specifications? And as an end user, is when you're writing specifications, there are several standards out there, such as the ANSI, the B11 TR1, which is the ergonomic guidelines for machine design. When you're writing specifications, do not rely on OSHA standards, because basically those are for you as the end user. Write specifications that affect and will drive designers and suppliers to provide you with the proper design applications for your particular machine. Second, educate your engineering team. Manage constraints. Leverage existing design systems. There are a lot of things out there that are already being used, and to look at those. Write questions to the right people. When you have your committee, get people that are affected by that machine. You have engineering designers, but also whether they're electrical or mechanical, hydraulic, pneumatic, but the people who are working with the machine on your committee. Get the operator, get the maintenance, get quality, get safety on your risk, because they're all going to have a different perspective of ergonomics and how it applies to them of not only doing their job, but not only doing it safely, but to reduce issues dealing with carpal tunnel syndromes, or CD. So anyway, and also to validate those designs and share the successes. Once you put it together and you do one machine, make sure it's working the way it's supposed to work, and share the successes, and then move on to the next machine and apply the same applications. Establish ergonomic design specifications. This is not only for the manufacturers, but you as the end user. What do you expect that the manufacturer, supplier, designer to put on your machine in a way that makes it the operator or the maintenance person can operate the machine in a most productive and efficient and safe way? Don't rely on suppliers to tell you that products and equipment are ergonomic design. This can lead to the dark side. Don't assume. That's why it's very important to write specifications as an end user of what you expect from an ergonomic perspective on your machine. The ergonomic design criteria should be defined and it should be measurable. Examine related standards, as I mentioned before. Attend professional workshops and or contact national safety organizations. Now, educate the engineering team. Technology is advancing by leaps and bounds. We all know that. Designers should not waive proper ergonomic training because maybe they had a class or two in college. Things change. This is a critical mistake. This is extremely important, especially from the standpoint that the engineers I worked for as an OEM were very, very good. Their function was that being form and function. I want to make 95 widgets every minute, and when I want to have a 90% efficiency, that was their incentive, that was their drive. And sometimes ergonomics is not a priority in reaching that particular goal. So it's very, very important, not only from the design standpoint, but from a user standpoint. Make ergonomic statement clear and hold people accountable and responsible. Now, management constraints. Reduce risk with a cost versus benefit analysis. Avoid design paralysis. Relying on previous design based on perceived effectiveness and time savings. This is very important to make sure you do your risk assessment, and in that risk assessment, you integrate your ergonomic assessment. Work as a change agent. Make sure we look at past design issues. Keep them fresh in mind. Suggest alternative options. Things change. Leveraging existing design systems. Again, as I mentioned before, ergonomics seems in some cases a lower priority and sometimes not a priority. Okay, this is very, very important from the standpoint it is integrated into the safety systems, how people work with the safety systems that are on the machine or with other controls such as your HMI system. The risk assessment is integral in identifying these hazards and related exposures as it pertains to ergonomic design. Ask the right questions to the right people. Now, this is what I mentioned before from the standpoint is not only as a designer, supplier, but as an end user, is get all the stakeholders involved that are going to work with that machine. Process engineers, design engineers, whether they be from electrical, mechanical, hydraulic, pneumatics. The maintenance people are going to maintain and service the machine. You've got the operators that are going to be working the machine, loading, unloading, clearing jams. So get everybody's perspective, into the input for designing the machine, particularly from an ergonomic perspective. Validate designs, share successes. Okay, we talk about avoiding reinventing the wheel with each design project. If you have something that is working well and can be applied to another project or another type of machine, use that. Basically, it's from the standpoint you have a good concept, it's working, that can maybe across the board be applied to other related machines. Don't duplicate bad designs. I've seen this particularly from electrical and designing the ladder logic in a particular control system where a design was put in, wasn't validated, and as an example, had 200 machines that had the improper logic because made a mistake in a bad design, and it was just cookie cutter across the other designs. Share your experiences, good or bad. Hey, this worked good, this didn't work good, and these are things that we have to focus on. Learn as an organization and as a designer and as an end user. Now, there are national standards and other sources. You've got, as I mentioned before, you have the NCP 11 TR1. The 2004 standard has been revised. It's now 2016. I sit on that standard with other individuals in the ergonomics field. You probably also know that somewhat years back, OSHA tried to put together a ergonomic standard, and that was surely rescinded. But again, there is information out there to give you guidance. There are also EN ISO standards. Even though they don't apply to you in the United States, they are very good best practices that you can utilize, as with ISO 60385. Then you have various ergonomic publications like Human Factors in Engineering and Design, Human Tech, Engineering Physiology, Basis for Human Factors, Ergonomics, to name a few. And if you need further resources, PILS has the competent resources to help you out with your ergonomic challenges in the future. Now, I want to share with you, here is an ergonomic safety assessment guide, as I mentioned to you before. I've been very fortunate, so is the National Safety Council. You can see this is available. This is not private information. Basically, this was designed by John Deere, which is very, very good. It is an example of an ergo checkup. I've used this in the past when working for an OEM. It's a very good document to give you some guidance as to make sure you're on the right track. So this is just partial, but that is available. You can get this possibly online, or you can get it through PILS. And in conclusion, remember, to err is human, to forgive is by design. Thank you very much. Stephanie?
Yes. Thank you, Doug. Great presentation. A few of you have already submitted questions, so we're going to jump right in. Let's see here. When you refer to HMI systems, would you mind to define or describe that?
Those are the that's what we call human-machine interface. It's your controls. On most machines will have a screen, and basically that's your control system and most of it's basically a little TV set that sits next to your machine, so it's a visual. When we talk about the screen, and I didn't talk about it in depth, but from the standpoint of designing, my perspective on the screens is I try to look at, because of the diversity of males and females in the industry, and I'm talking about my experience in working in the plastics industry, manufacturing plastic containers, is that what I've tried to use as a good practice, it's not written in stone, but from a design standpoint, is I try to utilize the 50th percentile of males which will keep me in the same ballpark as the 99th percentile of females. And if I have a fixed HMI screen on a machine and it's fixed, I try to keep that at about 60 inches from the center of the screen. That way it accommodates that 50 percentiles of male and the 99% of females. And I like to, it costs a little bit more, but in a diversity from the standpoint of various heights, whether they're female or male, is that if you could have a HMI, human-machine interface screen, it would be good to be able to have an adjustable screen where you can move it vertically, and it will move left or right for the different statures of males and females.
Okay, our next question. How can this be applied to ergonomic issues that are not an operator and a machine? We have personnel who connect rail cars to a process for offloading or filling, and I see the potential for injuries. However, there is not much I can do about the rail car.
Okay, we're talking about loading and unloading manually rail cars. I'm trying to understand the reference.
Okay, Scott, if you can please clarify in another message, then we'll follow up with this question in a moment.
Okay.
Okay. So moving on, slide 13. Can you please expand a bit on the controls?
Slide 13 is that the Anthropometrics overview? You said slide 13. Controls. I'm looking at slide 13, which is Anthropometrics overview.
Let's see here.
I want to make sure I pick up the right slide. When you said 13, mine yes. 13 of metrics overview.
Let's see here. The slide 13 in your presentation would be 19 on our console.
Okay. The force be with you or not? That particular slide? We talk about the two-hand controls?
I believe so. It says, can you please expand a bit on the controls?
Oh, okay. The controls, the two-hand, the swipes, the finger swipes, those, from the standpoint, there's no force put inside. It's reading the electrical impulses in your body to actuate those, and then they would work the same thing. You'd have to put both fingers, both within the swipes, to actuate that cycle, whether that's a power press, hydraulic power press, if you're actuating some other type of machine. And again, there's no force. And the gloves, it will read your electrical impulses through the gloves. So you don't have to be taking gloves off every 15 or 20 seconds to actuate the process. The other control is the two-hand controls on the side. As you are probably aware as a group, that OSHA has the two-hand controls. If they're sitting on top of the control box, they have to be at least 20 inches apart. And they have to have protective rings around them so a person cannot put their hand and their elbow across both the palm buttons and reach into the machine while the machine's running with their other hand. Now, the two-hand controls is basically I push the two-hand controls in, and if I happen to remove one hand from the control, the operation will stop. And to resume, I have to remove my left hand and then apply both hands in sequence, simultaneously. So the controls on the side, I can actually get rid of the protective rings. And again, I'm removing two motions of my wrist, to turn and then to push down into my fingers. So if you have two-hand controls, and you can design them in the way shown in the photograph, or you can use two-hand swipes, that is more convenient, it is more comfortable, and it'll be much more productive, and it reduces tremendously the repetitive motion injuries that come out of using two-hand controls, using your end of your palms or using your fingers.
Okay, and referring back to the rail car question, the connection of liquid rail cars where personnel connect fittings to the car for liquid offload. Scott was asking, how can this be applied to ergonomic issues? We have personnel who connect rail cars to a process for offloading.
Okay, one thing that we used in the plastics industry, unloading railroad cars for resin, was that the hose was basically tied to, and I don't want to say a bungee cord, but the hose, because typically in our particular situation, the unload area is at the bottom of the rail car, the tanker. And so that hose, being heavy, is supported by a cord that has some flex in it. So all I'm doing is moving it laterally, horizontally to the ground. So I'm really not picking it up. I'm just moving it from one location to the hookup point on the tanker. So by putting some type of overhead support on the end of the connection will reduce someone having to pick it off the ground and holding it while they're trying to connect it to the rail car.
Okay. So referring to slide 24, which is slide 30 on the presentation manager here, the twist and shout example, what are better alternatives have you seen when moving cases from a conveyor to pallet?
Okay. Good question. Let's see, we're on 30, right? Am I 30?
Correct.
Okay. Couple things. One is, first thing would be, is to raise the conveyor system, if possible, at that loading or unloading station, where when a person, and again, looking at the anthropometric dimensions, is taken into consideration, as I mentioned before, I've used the 50 percentile male arm length, things of that sort, is that from a standing position, I'm able to grasp the container without bending my back and using the short muscles. The other is putting the pallet to the left or right so I can step without twisting my body. I can step to the right, I can step to the left. The other is to have a self-leveling palletizer where when I move this off the conveyor onto the pallet staging area, that I've set that up so each layer of stacking will cause that levelizer to go down. So when I'm stacking from the conveyor to the pallet, it's always at the same height, and I'm not stacking above my head, and I'm not bending my back to put it on the pallet on the floor. So again, if you can raise the conveyor system up to a level where I'm picking this up without bending my back, that helps. Putting the pallet staging area to the left and right, not turning 80, but taking a step to the left 90 or to the right 90, and having the pallet on a self-leveling device.
Okay, and just to remind everybody, the slides are available for download in the green folder on your webinar toolbar. Okay, so our next question is, how often should you do an assessment?
Speaking as an end user, as an end user, you need to look at your equipment. Once you do the assessment, you have things set up. If you are making significant changes to the process, you're getting a new machine in, you're adding a conveyor, you're adding other elements to the process, you should go back and do a reassessment, an ergonomic reassessment, if there are significant changes. Or if you put changes in place and at initiation there's no problems, but maybe after a month or two there are some issues that have come up, then you should go back and reassess if there may have been something you missed in your assessment that needs to be addressed. So those are some of the factors in which you should go back and reassess it. But again, I would say any assessment, risk assessment, is a living document, and I would say at least on an annual basis to go back, even if you had no issues, go back and reassess it, just confirm based on your changes that everything, and then talking with the operators, talking with maintenance, see if they have any issues going forward. But that should all come out during your changes and with the participation and the involvement of people that work with the process.
Okay. How can we mitigate wrist discomfort in the wash rag scenario when a quarter of the workday is spent wringing rags?
Okay. Well, here's one of the things is there a particular device, piece of equipment that I could use from the standpoint of putting it into some type of machine or device that would basically would do that for me? Okay, from the standpoint that, yes, that is a situation that we can look at from the standpoint, is there technology out there, a machine where I could put this together and it would do the particular operation task automatically using some type of machine to wring out the rags. I think some of this is used in the car wash. And when you go to the car wash, there are some machines that they have because they go through a lot of wet rags. And so I think there's some technology out there that can be used to reduce that exposure of the wringing of rags.
Okay, moving to the textile industry, what kind of ergonomics are we looking at for stitchers?
I think from the standpoint, manual stitching of particular textiles, is that basically what we're looking at, is firstly the workstation. Is it a very detailed, so I have it up higher so my arms aren't down in a position which will cause extensive fatigue? Are we taking breaks? Maybe rotating around to some other type of operation where we use different muscles in the textile. So job rotation, moving around to a different task, again, where we use different muscles. And again, that workstation, is it up high where I'm using comfortably my short muscles rather than relying on my long muscles to maintain that position to do that particular task?
Okay. Our next question is, I've been told tasks should never be designed for the 50%/average person. It should always be for the 5 or 95%. Do you recommend raising a conveyor to the 50% or the 5% person?
if I raise it to the 50 percentile of males, I'm going to be covering the 99% of the females. So depending on what your work population is, you should be looking at designing as an end user, looking at that particular those particular ergonomic applications. For 5 percentile, you're looking at that could be used, but looking at from the standpoint, if I use the 5, that would be all right, but you're dealing with a situation where you're trying to get a level where you're dealing with males and females and trying to get that that acceptable height that addresses those particular factors dealing with height and reach of males and females. But again, that can be an appropriate area of the 5 percentile or the 25 percentile. But again, looking at what your population is, the number of the population, and what you're trying to achieve.
Okay. Well, it looks like that those are all of the questions that we have currently at this moment. You can continue typing in any questions in the Q&A box. Doug, do you have any final thoughts?
No, the thing I have is that it's extremely important from a designer or supplier is to, in your risk assessment on your machines for safety, efficiency, and productivity, that ergonomics is a key and significant element in that design, as it has an impact on the end user from the standpoint of, as I mentioned before, is the efficiency and the productivity and the comfort level. And from an end user perspective, there are certain things, particularly when you're dealing with legacy equipment, that it's been there for 15 or 20 years, and there are certain restrictions that you have to work within. But as an end user, I highly suggest, recommend, how you want to look at this is that putting in your specifications for new equipment that you have you have ergonomic design applications using certain standards as your support and justification in getting new equipment, and looking at, from as an end user, all the people that are going to be interfacing with that particular machine. So it's important, designer, supplier, and user. It affects everyone that is working with that machine or designing machines. It is very critical that ergonomics design as much as possible as a risk reduction measure in that particular area. So that, again, as I mentioned, we talk about human to the error in human from the standpoint of the best way is try to design it out or reduce those exposures by design, and ergonomics is a critical factor, again, as a designer, supplier, and as an end user with equipment you already have.
Okay. Well, I'm afraid that we've run out of time. On behalf of EHS Today, I would like to thank you, Doug, for the presentation this afternoon, and to PILS Automation Safety for making this webcast possible today. I would also like to thank you, our audience, for your time and attention. We hope that you found today's webcast valuable and will return for future EHS Today webinars. Have a great remainder of the day.